Now we want to solve some application problems whose solutions depend on solving systems of equations in 2 variables and in one case in 3 variables. Here's our first example. One number is 3 more than twice another. The sum of the numbers is 18. Find the numbers. Let's let x and y be the numbers. Well, first of all, their sum is 18, so x plus y is equal to 18. That's one equation in a system of equations that will together describe this situation. Now I look over here and I see that one number is 3 more than twice another. Well, I'll just let y be equal to 3 more than twice the first number. So here's twice x plus 3. So this system of equations that I've written right here, x plus y equal 18 and y equal 2x plus 3, is a system of equations that together describe the situation described in this problem right here, the situation written in this problem right here. The second equation tells us that one number is 3 more than twice another, and the first equation tells us that the sum of the two numbers is 18. Now this is a problem that we could have solved previously just using one equation in one variable. Sometimes people like to do 2 equations in 2 variables a little better because it helps sort of organize the information into smaller little bits. You don't need to look for one equation that just describes the whole situation. You're asked for 2 different things in the problem. You can let x be one of them and y be the other one, and then write a system of equations that together describe the situation in the problem. Now this looks like a good problem to solve by substitution. Take 2x plus 3, replace y with it in the first equation, and then solve for x. That'll be one of the numbers, then the other number will be what we get for y. I won't solve that system. I want to go on and set up a couple more of these application problems. Problem number 2, we have Susan invest twice as much money at 7.5% as she does at 6%. If her total interest after a year is $840, how much does she have invested at each rate? So I'm going to solve this problem by setting up a little table, and the table is going to have 2 rows and then a couple of columns right here. Let me extend it over this way right here. Now in this column I'm going to set this up so I have dollars at 7.5%, and this next column I'm going to have dollars invested at 6%. And then in my 2 rows here I'm going to have the number of, so that'll be the number of dollars at 7.5%. Here will be the number of dollars at 6%. And down here I'm going to write the interest. The interest on. Now, setting the problem up this way gives me some little squares here to fill in according to what's written in the problem. Now I'm asked here for how much she has invested at each rate, so I want to know 2 different things. How many dollars does she have invested at 7.5%, and how many dollars does she have invested at 6%? So I'll use 2 variables. X I'll let be the amount that's invested at 7.5%, and y will be the amount invested at 6%. So I set the problem up by letting x be this amount, and y will be equal to this amount. So x stands for the number of dollars that are invested at 7.5%. Y stands for the number of dollars invested at 6%. Now I'll fill in these 2 squares right here, knowing that these x dollars earn 7.5% interest. So 0.075 times x is the amount of money that's earned in interest on these x dollars in a year. Now these dollars y are invested at 6%, so the amount of interest that's earned on those y dollars is 0.06y. So you can see by this table right here, I've let x be the number of dollars invested at 7.5%, y is the number of dollars invested at 6%, 0.075 times x is the amount of interest that's earned on these dollars, and 0.06y is the amount of interest that's earned on these dollars. Now, what's the relationship between x and y? Well, what it says up here is that Susan invests twice as much money at 7.5% as she does at 6%. So the dollars over here at 7.5% are twice as large as the dollars over here. So what that's going to tell me that x is equal to 2y. The number of dollars at 7.5% is twice the number of dollars invested at 6%. The second equation I'm going to get comes from the fact that she earns $840 in interest after the first year. That comes from the interest on these X dollars plus the interest on these Y dollars right here. So 0.75 X plus 0.075, so let me just take this away right here, move it over here. 0.075 X plus 0.06 Y is equal to $840. Now I would solve this system of equations by possibly multiplying this second equation through by 100 and then substituting 2y for x. So I take 2y, which is x, and put it into this equation, maybe multiply this through by 100 to clear it of decimals. But it's 0.075x plus 0.06y is equal to 840. These two equations together describe the situation written in this problem right here. One of the equations has to do with the number of dollars, and the other equation has to do with the interest earned on the dollars. Let's go on to our next problem. So here we have how many gallons of 20% alcohol solution and 50% alcohol solution must be mixed to get 9 gallons of 30% alcohol solution. I'm going to begin this problem with a little chart also that will help me organize my information. So I'm going to have over here gallons of 20% solution, and over here I'm going to have gallons of 50% solution. Now, along this row I want the number of, and over here I want the alcohol in. So let's let the number of gallons of 20% solution be represented by X. The number of gallons of 50% solution will be represented by Y. Well, that tells me that since I have 9 gallons total, X plus Y must come out to be equal to 9. So that's one equation in a system of equations that together will describe the situation in this problem. Now, how much alcohol is in this X gallons that's 20% alcohol? Well, the answer is 20%. So 0.20 times X is the amount of alcohol in this solution. In this Y gallons that's 50% solution, that's 50% alcohol, the amount of alcohol is 50%. So 0.50 times Y. So the amount of alcohol in the 20% solution, which is 0.20 times X, plus the amount of alcohol in the 50% solution, which is 0.50Y, has to come out to be the total amount of alcohol that we want in the final solution. And the final solution is 9 gallons, that's 30% alcohol. So the number of gallons of alcohol in that final solution must be 30%, so 0.30 times 9. So you can multiply this equation through by 10, and you would eliminate all the decimals in it. After you multiplied this out, I think you might have to multiply through by 100. No, multiply through by 10. And then you could use the addition method right here, or substitution, maybe solve it by matrices, or using Kramer's rule. But in any case, this system right here of these two equations together, they describe the information that's given in this problem. So a system of linear equations in two variables to solve this application problem. Let's look at one last problem. I wanted to have one problem that had a system of 3 equations and 3 variables, and this will be that problem. Here we have a collection of nickels, dimes, and quarters that consist of 9 coins with a total value of $1.20. If the number of dimes is equal to the number of nickels, find the number of each type of coin. So I'm going to let X be equal to the number of dimes. Then I'll let Y be equal to the number of nickels. And Z will be equal to the number of quarters. So X is the number of dimes, Y is the number of nickels, and Z is the number of quarters. Now I want to go back. I have 3 variables right here, so I need 3 equations that together will produce a system of equations that describes the situation written in this problem. So let's see. First of all, I have a total of 9 coins. Well, that must be X plus Y plus Z, because those variables represent the number of dimes, number of nickels, number of quarters. So my first equation is X plus Y plus Z is equal to 9. Now I read further, and it says that, let's see, the total value is $1.20, or 120 cents. Well, each dime is worth 10 cents. So 10 times the number of dimes is the amount of money in cents in dimes. Each nickel is worth 5 cents, so 5 times the number of nickels is the amount of money that's in nickels. And I have Z quarters, and each quarter is worth 25 cents, so 25 times Z is the amount of money I have in quarters, and that has to come out to be 120 cents, since I've written it in cents. Instead of writing $1.20 and having some decimals to work with, I'll just write it this way. Okay, I need one more equation, and let's see. If the number of dimes is equal to the number of nickels, well, the number of dimes is X, the number of nickels is Y, so my last equation says that X is equal to Y. So there's a system of 3 equations in 3 variables. X is equal to Y, so I could use some sort of substitution maybe, or write this in standard form. There's a lot of ways to solve this system. So some word problems lend themselves well to a system of 3 equations and 3 variables, like this last one. But in any case, there's a variety of application problems that we can solve whose solutions depend on systems of equations.